Overview of pressure measurements. Pressure is measured as a force per unit area. Pressure measurements are important not only for monitoring and control of pressure itself but also as a means of measuring other parameters, such as level and flow, through differential pressure. The pressure P of a force F distributed over an area A is defined as P equals F divided by A. Pressure is one of the most common measurements made in process control. It is also one of the simplest in terms of selecting a specific type of device. One of the key items to consider is the primary element, strain gauge, Borden tube, spiral, etc. Primary element materials should be selected to provide sufficient immunity to the process fluids and at the same time provide the required measured accuracy under the process conditions encountered. Why we measure pressure? For common reasons. 1. Safety. Prevent pressurized pipes and vessels from bursting. 2. Process efficiency. Variation of pressure below or above a set point will result in scrap rather than usable product in some manufacturing process. 3. Cost saving. Preventing unnecessary expense of creating more pressure or vacuum than is required saves money. 4. Measurement of other variables. Rate of flow through a pipe. Level of fluid in a tank. Density of fluid. How two or more liquids are set in a tank interface. Types of pressure sensing configurations. Absolute pressure, measured above total vacuum or zero absolute. Zero absolute represents total lack of pressure. Atmospheric pressure, the pressure exerted by the Earth's atmosphere. Atmospheric pressure at sea level is 14.696 psi. The value of atmospheric pressure decreases with increasing altitude. Barometric pressure, same as atmospheric pressure. Gauge pressure. The pressure above atmospheric pressure. Represents positive difference between measured pressure and existing atmospheric pressure. Can be converted to absolute by adding actual atmospheric pressure value. Differential pressure. The difference in magnitude between some pressure value and some reference pressure. In a sense, absolute pressure could be considered as a differential pressure with total vacuum or zero absolute as the reference. Likewise, gauge pressure, defined above, could be considered as differential pressure with atmospheric pressure as the reference. Types of pressure instruments. Pressure gauges, vacuum, compound, absolute, gauge. Differential pressure gauge. Pressure switch, vacuum, absolute, gauge. Differential pressure switch. Pressure transmitter, vacuum, absolute, gauge. Differential pressure transmitter. Pressure gauges. Measuring principle. Borden tube measuring element is made of a thin-walled C-shaped tube or spirally wound helical or coiled tube. When pressure is applied to the measuring system through the pressure port, socket, the pressure causes the Borden tube to straighten itself, thus causing the tip to move. The motion of the tip is transmitted via the link to the movement, which converts the linear motion of the Borden tube to a rotational motion that in turn causes the pointer to indicate the measured pressure. Differential pressure gauges. Measuring principle. Differential pressure gauges have two inlet ports, each connected to one of the volumes whose pressure is to be monitored. In cases where either input can be higher or lower than the other, a bidirectional differential range should be used. Diaphragm seals. Measuring principle. Diaphragm seals, also known as chemical seals, isolate pressure measuring instruments from the process media. The system pressure is transmitted to a fill fluid in the upper housing of the diaphragm seal, and from there to the pressure measuring instrument itself. Pressure and differential pressure switch. Pressure or vacuum switch, a device that senses a change in pressure or vacuum and opens or closes an electrical circuit when the set point is reached. Pressure switches serve to energize or de-energize electrical circuits as a function of whether the process pressure is normal or abnormal. The electric contacts can be configured as single-pole double-throw, SPDT, in which case the switch is provided with one normally closed, NC, and one normally open, NO, contact. Alternately, the switch can be configured as double-pole double-throw, DPDT, in which case two SPDT switches are furnished, each of which can operate a separate electric circuit. Pressure and differential pressure transmitter. A pressure transmitter is used where indication and/or record of pressure is required at a location not adjacent to the primary element. A pressure transmitter is used for both indication and control of a process. A pressure transmitter is used where overall high performance is mandatory. Both electronic and pneumatic transmitters are used. These can be either gauge, absolute or differential pressure transmitters. Units of pressure measurement.
If you like this video, please subscribe this channel and press bell icon to get notification of new videos. Thank you so much for watching and have a nice day.